We're now going to look at general vector problems, example 3. So we've got our vector diagram below. We're given the vector OD, it's small d. We're given the vector OA, that's small a. We're also told what the vector DB is in terms of ND, and we're also told what vector AC is in terms of ND. We're then told that the length OA and the length AB are in the ratio k to 1. So what that means is the length OA is k times the size of AB. So what we could do is put that in our diagram, the ratio. So O to A, if you like, is k parts. And then A to B is worth 1 part. And then overall, the entire length from O to B would be k plus 1 parts. Now, there's actually something else we can do here. Because we know the vector that represents OA, and we know that OA is k times bigger than AB, well, that means that AB is k times smaller than OA. So if OA is vector A, then AB is going to be vector 1 over k times A. It's k times smaller, so you divide by k. Okay, that's quite tricky. Okay, so this length is k times the size of this one. So that means this length is k times smaller, so you divide by k. So it's 1 over ka. So that's the important bit in the question. Part A then again asks us to work out this unknown k. Now, we want to try and set up a vector equation such that we have k in it. Now, k features in the vector AB. What we could do is we could use the triangle BDO to set up an equation, because if we use this triangle, we actually know what all the vectors are. We know what AB is, we know what OA is, we know what OD is, and we also know what DB is. So what we're going to do is we're going to set up an equation using triangle and its ODB. Okay, so it doesn't matter which vector in the triangle you start with. You could start with DB and set it equal to the sum of the other two. You could start with OD and set it equal to the sum of the other two. It actually doesn't really matter. I'm going to just pick DB. So I'm going to start with DB. So the vector DB is the sum of the other vectors between its tail and its nose. So traveling from D to B is the same as moving along this vector, which would be negative D, because you're moving against the arrow. So that would be negative D. And then we're adding on these two vectors. Okay, so that would be plus A plus 1 over Ka. Okay, now we can sub in what dB is in terms of A and D. So if you go back up here, dB is 3 over 2A minus D. So 3 over 2A minus D. That's equal to minus D plus A plus 1 over K times A. Now, again, a bit like the previous example, you'll notice there's a minus D in this side of the equation and there's also a minus D in that side, so they cancel out. If you move one over to the other side, they'll wipe each other out, so that's great news. So they'll wipe each other out. So we've got 3 over 2A on this side. Now what we can do on the other side is we could actually factorise. We could lift A outside. A is common to both terms, so that we only get one A on this side. So we could lift A out, and we're going to have 1 plus 1 over K. So again, you'll see there's only one a on each side. So we're going to equate the coefficients of a. So we're going to get 3 over 2 is equal to 1 plus 1 over k. So we've now got a nice little straightforward equation with just k in it. So what we're going to do is get rid of the fractions. So you can multiply through by 2 to get rid of the 2, and then you can multiply through by k to get rid of the k, but why not just do both at the same time? Let's multiply through by 2k. So if we do that, we're going to be left with 3k on the left, and that's equal to 2k plus 2. And again, simple, solve, move 2k over, we'll get k is equal to 2. And that's it. So k is 2. And that's our solution for part A. Now, part B is asking us then to prove that the shape ADCB is a parallelogram. It looks like a parallelogram, but how do we prove it's a parallelogram? Well, you have to do two things. You have to show that the opposite sides are equal. They're the same length. And you also have to show that they're parallel, because that's why it's a parallelogram. So we have to show that opposite sides are equal and opposite sides are the same length. So we're going to have to work out the vectors for AD and BC. And likewise, we're going to have to work out the vectors for AB and DC. So let's now skip to part B. So to prove it's a parallelogram, we have to show, first of all, that opposite sides are equal and parallel. Okay, let's first of all start with, let's start with AD and BC. Let's get the vectors for those. Let's start with AD. So AD, so travelling from A to D is the same as going from A to O and then O to D, so it's going to be negative A plus D. Put brackets around that to keep it all together. We're going to do the same for BC. Now, travelling from B to C, there's lots of different ways we could do it. Probably the easiest way would be to go from B to A and then A to C. Now remember, we worked out K was 2. So B to C is the same as B to A and then A to C. So B to A, we have to make that vector negative because we're going against the arrow. So it's going to be negative a half A. And then we're adding on AC, and AC is D minus a half A. So plus D minus a half A. And then tidy up. So we've got minus a half A minus another half A. That's just going to be minus A, minus 1A. And then we've got plus D. Now that's super news. So first of all, we know now that AD is equal to BC. They're exactly the same. They're identical. So that tells us they're the same length. So therefore, AD and BC are the same length. So I can also then write this equation as AD equals 1BC. Why am I doing that? Because, well, if two vectors are parallel, then you're multiplying one of them by a constant to get the other. So I'm just, BC is the same as 1 times BC. So therefore, AD and BC are parallel. So, in other words, we've shown that the opposite sides, AD and BC, are the same length, and they're parallel. So we're now going to do the same with the other two sides. We're going to do the same with AB and DC. So let's start with AB. Now, AB is 1 over k times A, and remember 1 over k is just 2, so that's just a half A. Easy. Let's work out DC now. So vector DC. Now, travelling from D to C is the same as going from D to A and then A to B. Okay, so D to A. Now, how do we get D to A? Well, DA is negative D plus A. Okay, so that's going to be negative D plus A. Okay, so we want DC. So travelling from D to C is the same as going from D to A, and D to A is negative D plus A, and then we have to add on AC. Okay, so again, AC is D minus a half A, so that's plus D minus a half A. Okay, let's tidy it up. So we're left with minus D plus D wipe out, and then we're left with 1A minus a half A is just going to give us a half A, which is fantastic. So we've now shown that AB and DC are the same, so they're the same length. So therefore AB is equal to DC. So therefore AB and DC are the same length. And then again, if I take this equation here, I can rewrite the right hand side as 1 multiplied by DC. So AB is equal to 1 DC, which therefore implies that they're parallel. So we've just shown that opposite sides are equal and parallel, so therefore therefore the quadrilateral ABCD is a parallelogram. Okay, so another really good question. So those are the things to look out for in general vector problems. You're always trying to set up a vector equation of some sort to either work out an unknown vector or work out a constant, or in this case to make a geometrical proof. In other words, show that a particular shape is a parallelogram.